Hey everyone. Okay, so in our next lesson on linear functions, we're going to keep thinking about the concept of slope, but we're going to dive a little deeper and just compare slopes of lines that would be parallel to each other and lines that would be perpendicular to each other. I'm hoping as you're walking into this section that you have a concept in your own mind right now as to what parallel and perpendicular mean. But if you don't, that's okay. We will dive into that as we go. Okay, so first thing I want you to do here is I've given you this question. A line passes through the points 3, 4 and -5, -2. Another line passes through 3, 1 and -5, -5. Determine the slopes of both lines and draw both on a grid. I'd like you to determine the slopes first. I want you to have some practice using that slope formula that we talked about yesterday. Remember, it's m equals y2 minus y1 all over x2 minus x1. So go ahead and pause me, find the slope of both of these. What you're going to notice, I just denoted that with a subscript 1 there because I'm going to talk about two different slopes here. So the slope of line 1 is how we could say that. I went 4 minus -2, so I went y2 minus y1 over x2 minus x1. Remember, because I started with the 4, I was starting with this point here that I'm circling. So because I started with the 4, I also had to start with the 3. Those are things we talked about yesterday. So 4 minus -2 and 3 minus -5, that's going to give me a slope of 3 over 4. Then when I go to do the second line, I'm going to denote that with m subscript 2. And I went 1 minus -5 and 3 minus -5, and that also gives me 3 over 4. So these slopes happen to be the same. Now what I want you to do is I want you to pause me and plot all of this and draw the two lines so that we can get a visual of what those two lines look like. So then what you noticed is the blue line is there and the red line is here. And now if I asked you to describe these lines to me, I would want you to tell me that these lines are parallel. Okay, parallel are two lines that will never intersect. So they're always the exact same distance apart from each other. Now, if you think about what slope means, slope refers to the steepness and direction of a line. It would make sense that parallel lines should have the exact same slope, because if they don't have the same slope, at some point they're going to intersect each other. Okay, so your first take-home message here is parallel lines should always have the same slope. Okay, and that's going to be useful as we go through this. Now, we're going to go through a little investigation. You've got kind of 4 different pairs of line segments to the right of this slide here. I want you to classify each as parallel, perpendicular, horizontal, vertical, and intersecting. What I would want you to have found there is I would want you to call these guys parallel. Both of those guys are perpendicular, and then these ones we're just going to call intersecting. Okay. Now, determine the slopes of each one. So pause me. You don't have to use a slope formula here because they're on a grid. Remember, when you have a grid, you can just go rise over run. So go from one point to the next point. How far up, down do I have to go? And how far left, right do I have to go? Rise refers to the up, down. Run refers to the left, right. Okay. Okay, so you should have gotten 3 over 2 for AB, and then 3 over 2 for ZY. CD was undefined, and FE was 0. You got -2 over 5 for MN, and you've got -4 over 3 for KL. And then you had 2 over 3 for HG and -3 over 2 for IJ. Okay. Okay, what do you notice about the slopes of parallel lines? Again, these guys were my parallel lines, and we see, again, that they are the same. Okay. What do you notice about slopes of perpendicular lines? Well, that one might be a little harder to notice. Most of you would probably feel comfortable to say, sorry, I'm just going to switch my color here. These guys are probably perpendicular. I'm going to ignore those guys for a sec, and I'm going to tell you that these guys are also perpendicular. So let's look at these guys for a sec. How would you compare 2 over 3 with 3 over 2? What I want you to see there is 2 things have happened. First of all, the fraction has flipped. So what was on the top became the bottom, and what was on the bottom became the top. Second of all, one of them is positive and one of them is negative. Okay, so when we flip something in math, we call that the reciprocal. Okay, a reciprocal means we have flipped it. We talked about the word reciprocal when we did negative exponents. A negative exponent tells you to take the reciprocal of the base. Okay, so reciprocal just means to flip. The fact that the signs are changing we can't just say we take the reciprocal, we say we take the negative reciprocal. Saying we're taking the negative of something refers to the sign changing, because if we took a negative of a negative, it would be positive. And if we took a negative of a positive, it would be negative. So taking the negative of something always refers to changing the sign. So we would call these guys negative reciprocals, okay? Okay, now, what do you notice about the slope of a horizontal line? We're gonna go over here. Slope of a horizontal line is 0. That should be familiar to you from yesterday's lesson. And then slope of a vertical line should be undefined, which should also be familiar to you from yesterday's lesson. Are the horizontal lines and perpendicular, sorry, are the horizontal and vertical lines perpendicular? Well, yes, they are. Do they follow what you noticed in number 4? They actually do. It's just a little bit harder to notice, okay? If I talked about FE there as a slope of 0, and I took the negative reciprocal of that, the negative reciprocal of 0, that's like 0 over 1. So the negative reciprocal of that would be negative 1 over 0, and you can't divide by 0. So as soon as you get that division by 0, that gives you your undefined slope, okay? Okay, what do you notice about the slopes of the intersection lines that are not perpendicular? So these guys here were the intersecting lines. And all you need to notice there is that they're different. We don't have any connection between the two of them, okay? All right, so your take-home message from this little investigation is the following. The slopes of parallel lines are always the same. The slopes of perpendicular lines are always negative reciprocals of each other. The slope of a horizontal line is always 0, and the slope of vertical lines are always undefined. Okay, just some formal definitions for you. Parallel lines never intersect. They are always the same distance from each other, and their slopes are always equal to each other. Parallel lines are denoted with 2 vertical lines, or sometimes you'll see them as 2 slanted lines as well. Perpendicular lines, they intersect at a 90-degree angle. Their slopes will be negative reciprocals of each other. And perpendicular lines are often denoted in math as it looks kind of like an upside down capital T, okay? All right. A line passes through the point 0, -1 and 2, 5. Another line passes through the points -3, 4 and 3, 2. Algebraically determine whether the two lines are parallel, perpendicular, or neither. In order to answer this question properly, remember algebraically determine is kind of a big phrase there. It means you got to show me something, okay? You can't just say what they are. You have to arrive at their slope. So you have to use the slope formula. You have to plug in the numbers. You have to show me what the slopes equal. So that's what we're going to do. We're going to find the two slopes. You should pause me and do that on your own first. So for the first guy, I went 5 minus -1 over 2 minus 0, and that gave me a slope of 3. For the second guy, I went 2 minus 4, y2 minus y1, over 3 minus -3, and I got -1 over 3. I now want to compare those two slopes, and I see, remember 3 is 3 over 1, so I see that these two slopes are negative reciprocals of each other. Therefore, they're perpendicular. The lines are perpendicular to each other, okay? So you have to tell me what you see and how that tells you what you know, okay? So make sure you give me some sort of a concluding sentence here. So the slopes are negative reciprocals of each other, so the lines are perpendicular to each other. What do you get when you multiply a number by its negative reciprocal? Pick any number you like. 5? Okay, sure. So 5, what's the negative reciprocal of 5? Well, that'd be -1 over 5. So if I multiply those guys together, this is like 5 over 1. So that's going to give me -5 over 5, which equals -1. Now, you can do that with any number you want. When you multiply a number by its negative reciprocal, you're going to get -1. A times -1 over A is going to give you -1. So for perpendicular slopes, sometimes we also, instead of just saying the slopes are negative reciprocals of each other, sometimes we say the two slopes multiplied together will give me -1, okay? All right. If a line has a slope of 4 over 5, what is the slope of a line perpendicular to this one? Well, if I want to be perpendicular, I have to take the negative reciprocal of that. So that'd be -5 over 4. If I want to be parallel, then I needed to have kept it the exact same. So I started with a slope of 4 over 5. I will keep a slope of 4 over 5, okay? if a line has a slope of -6, then what's the slope of a line perpendicular to that one? So what's the negative reciprocal of -6? That would be +1/6. And if I want to be parallel, I need to be the same as what I started with, which would be -6. Okay? Okay, a student was asked if line segment AB with A -9, 2 and B -3, 4 is parallel to line segment CD with C being -7, -7 and D being 1, -3. The student was asked, the student sketched a graph and concluded that they appear parallel. Is it correct to assume from a sketch that the two lines are parallel? I want that to be a resounding no. Okay, you can never eyeball math. So important. Okay, when you are drawing a sketch of something, by definition, the word sketch usually means it lacks accuracy. So something that is close to the same may look parallel, even though it may not be parallel. Okay, I'm going to show you a computer-generated graph. And you're going to see very obviously with the computer-generated graph, these two lines are not parallel. Okay, but you can see that they're pretty close. And so if one's just sketching by hand, it's easy to assume that it could be parallel. Okay, so you can never ever eyeball something and make a judgment in math just based on the eyeball. Okay, so how do you prove it? You'd have to calculate both slopes. So let's do that. Determine if the student is correct. Now, this word determine, you're going to see me start highlighting it. It's super important because I want to make sure you realize determine always means you need to arrive at the conclusion. When something says determine, it's not enough, it's not good enough for you to say to me, oh, well, the answer is this because it works this way and show me that it works. That doesn't determine it, okay? That shows me it works, but it doesn't determine it. Determine means you have to be able to algebraically arrive at that solution, okay? So we're going to calculate the slopes. Slopes on a picture is rise over run. So this red graph, I go up 2 and over 1, 2, 3, 4, 5, 6. 2 over 6 would reduce to 1 over 3. The green graph, up 1 over 2, up 1 over 2. So the green graph has a slope of 1 over 2, and we know that 1 over 3 does not equal 1 over 2, so the lines are not parallel because the slopes are not the same. Okay, now, this is a great test question. A triangle has vertices A being -5, 1, B being 3, 2, and C being -3, -2. Determine if it is a right angle. Again, I have lots of kids on a test, they will draw this and they'll say, yep, it looks like there's a right angle right there, so I'm going to say, yes, it's a right angle. That gets you nothing, okay? Nothing. Be super careful of that. You have to find the slopes of all three sides of your triangle. Now, if you're trying to figure out the three sides of your triangle, you would have side AB, you would have side BC, and you would have side AC. So those are your three sides. So find the slope of AB, find the slope of BC, and find the slope of AC, and then you can compare the slopes. This is great slope practice as well, so pause me and do that yourself. That also gives me a chance to have a sip of tea. Okay, so you have unpaused me, and my mouse is not on, just a sec. Okay, so the slope of AB, you should have gotten 1 over 8. 2 minus 1 over 3 minus -5. The slope of BC, you should have gotten 2 over 3, which was -2 minus 2 and -3 minus 3. And then the slope of AC, you should have gotten -3 over 2 because you went -2 minus 1 and -3 minus -5. Now we are comparing those slopes, and I see this is very exciting to me. 2 over 3 and -3 over 2, those guys are negative reciprocals of each other. Because they're negative reciprocals of each other, that means they're perpendicular to each other. And because they're perpendicular to each other, that means there's a right angle there, which means this triangle is a right triangle, okay? Now, all those wonderful things I just said, I need to hear them from you. So you have to give me, like, it's not enough to just show me this beautiful work. Although the work is beautiful, this would be like a 4-point question where you'd get 1 point for every slope, and then you'd get a point for why you chose the conclusion that you did, okay? So I will say here, The slopes of BC and AC are negative reciprocals of each other. So they are perpendicular and the triangle is a right triangle. Okay? Awesome. A line segment has endpoints A, -2, 3, and B, 8, -3. Determine the coordinates of point C so that the line segment AC is perpendicular to AB. Now, if you're lost there, let's just draw ourselves a little picture, okay? So I have a line segment A, which is -2, 3, so that might be there. And B is 8, -3, so 8, -3. So this might be A and this might be B, okay? And we've got this line segment right here. Determine the coordinates of C so that AC is perpendicular to AB. So what we're saying here is, notice that both of them involve A. So essentially we want to draw a perpendicular line using point A and some other point. So we're gonna have a line that's perpendicular. Okay, so it'll form a right angle like that. Okay, and then I need to find some point on this line that I can call C. That's what we're doing right now. Okay, well, it'd be helpful to know what the slope of AB is first. So let's figure out the slope of AB. y2 minus y1 over x2 minus x1. We end up with a slope of -3/5. Now, I know that the perpendicular slope, which would be in this guy here, my red line is my perpendicular slope. I know that that slope has to be the negative reciprocal of AB. So if AB is -3/5, this guy has to have a slope of 5/3. I switch the sign and I flip it, okay? So let C equal xy, I just mean that's some random point, okay? And I know that the perpendicular slope has to be 5/3 because I took the negative reciprocal of -3/5. So now, from here, I know that this is the point -2, 3. So I could go up 5/3 from there. So up 5, well, that 3 would turn into an 8. And over 3, the -2 would turn into a 1. Okay, so up 5/3, I might have the point 1, 8. Or I could go down 5, back 3. So if I went down 5, I'd be at -2. Back 3, I'd be at -5. So that might be like -5, -2. Okay. Now remember, this is just a sketch, so my diagram is not necessarily in proper scale. Like that 1 should actually be on the other side. That's okay. I just want you to understand what I'm doing here. So I went up 5, so my 3 turned into an 8. And I went right 3, so my -2 turned into a 1. Or I went down 5, sorry, I did that wrong. Oh, no, I didn't. That was fine. I should pay attention. 3 down 5 is -2, that's totally fine. And then -2 left 3 would get me to -5. Okay, so those are 2 options for C. Technically, there's an infinite amount of options for C because you could keep doing that. You could just keep applying the slope and get point after point after point after point. Okay. So those were my 2 options that I just showed you visually for C. Okay, so that ends our conversation on parallel and perpendicular lines. Next lesson, we're going to start getting into equations of lines and how to write equations of a line. So next up will be slope by intercept form. Okay, in the meantime, make sure you practice your homework and connect with me if you have any questions. And don't forget to smile because you're doing math. Take care, guys.